as well. All right, so we're going to continue now. We're going to talk about probability. So the goal for today is we're going to do one more counting method. So in the previous lessons, we were doing all that multiplication, the fundamental counting rule. We're going to talk about mutually exclusive events today, and then we'll talk about probability. All right. All right, so let's go back to this question here. So Rita is deciding what her elective will be next year. Her options for each are recorded below. Now pay attention closely to the parts that are in bold there, underlined. It says this year she is allowed to have 2 electives, and she could pick 1 art class and 1 foreign language class. And the question is, how many ways can that happen? Well, she has to make, let's go back to our questions that we've been asking ourselves when we're doing counting. She has to make how many choices here? She has to make 2. She's got to decide what one of her elective classes will be, which art class it will be, and then which language class she's going to pick, right? Now, how many ways can she pick the art class? 3 ways. How many ways can she pick from a a foreign language class? 3, for a total of 9. She can have 9 ways to choose a class. She could do painting in Spanish, painting in French, painting in Latin. Or she could do sketching in Spanish, sketching in French, or sketching in Latin, or sculpting in Spanish, sculpting in French, sculpting in Latin. So if she can take 1 from each area, then there's 9 possibilities. Now let's go ahead and change this word problem slightly though. Once again, she's deciding what her elective is going to be next year, but let's read the bottom. The bottom part has changed. Notice the bold and underlined parts. What's different there? She's only allowed to have 1 elective this time. And there's also the word or, meaning that she can't have both. So she can pick either an art class or a foreign language class. So she can pick between the art or the foreign language. Now let's just use some common sense here. How many options does she have for art? How many for language? Now here's where our common sense can come in. She's allowed to pick 1 of these. How many is there she can pick from? There's 6. Notice we add in this case. So the key word you're looking at here for this is, if it's and, you're taking 1 from each, you would multiply them. But if we're talking about an or situation, either or, you add the options together to get the total number. Okay? That's called mutually exclusive whenever you have only 1 of the events possible at a time. So you guys have this written down in the notes I printed out for you. So mutually exclusive events are 2 events that cannot occur together. That was like in the last example I gave you. She could not take both an art and a language class. She had to take 1 or the other. And then to determine the number of ways that mutually exclusive events can occur, find the number of ways for each event and then add them. And that's what we did. All right. So suppose you roll a dice. How many ways can you roll a sum of 7? And here's your key word that indicates we're dealing with mutually exclusive events, or 8. Well, we have 2 things to consider. Ways of getting 7s and ways of getting 8s. Well, let's look at this chart. Now on this chart, this is a really popular chart, and this is a good reason to keep the notes that you guys have today. This chart is going to be on tests, it's going to be on quizzes, it's going to be on homework. This is the only time I'm going to make it for you. So you can use your notes so it's always there for you. This represents 1 dice along the top and all the possible outcomes, 1, 2, 3, 4, 5, and 6. And this represents another dice down the side and all the outcomes. And when you put them together, these are the sums inside of here. Okay? So, for example, 1 and 1, if you roll 2 ones, you get 2, right? Or if you roll a 4 and a 5, you get 9, right? So, here's our question. 7s. How many ways can you roll 2 dice and get 7s? Well, let's take a look. Here's one way you can get a 7 with a 6 and a 1, right? Another one, another one, another one, another one, another one. That's a total of 1, 2, 3, 4, 5, 6. There's 6 ways to roll a 7, it looks like. Now let's look at the 8s. How many 8s are there?
5.
Is it possible to roll an 8 and a 7 at the same time? No. So what am I going to do with these outcomes here? You add them because they're mutually exclusive for a total of 11 possibilities. So there you go. That is an example using dice of mutually exclusive events. All right. Now let's take a look at another example here. You're allowed to make up your own password. However, your password must contain 3 different letters and 1 number. Okay? How many possibilities are there? Now, we asked a question like this back in chapter 9.3 or unit 9.3. But I made a special little note in parentheses at the end of that word problem. I said, in that problem, all the letters come first and then the numbers. I deliberately set them in special places. And the way we did it was, well, we made our blanks. We filled in the number of ways for the letters and the number of ways for the numbers and multiplied straight across. But we have a problem here on this one. This is a new situation. I'm not telling you where the numbers and letters go. In other words, they could be anywhere. And so let me show you how this can be a mutually exclusive case. First of all, if I've got 3 letters and 1 number, how many choices do I have to make? You've got 4. But here's the problem. I've got 1 number. I don't know what spot that number is going to be in. Okay? It could be here in the front. Where else could it be, though?
The middle.
Right? And it can also be... Can somebody tell me why each of these 4 outcomes are mutually exclusive? Go ahead, Jesse. That's right. You can't have 1 number in 2 different places at the same time, right? So it's either going to be this case, this case, this case, and here's your key word, or this case. You can't have the 1 number be in 2 different places at the same time. So we have to find the probability, the number of ways for each of those cases, and then what am I going to do? You add them all together because they're all mutually exclusive. So now at this point, each of these though is done just like we did in the past. Let's say the numbers in the front. How many different numbers can I put here? There's 10, 0 through 9, right? Now I need 3 keyword different letters. So how many options do I have for the first letter here? 26 followed by 25 because it has to be different, so you lose an option, and then 24. Now, supposing that the number's here, how many numbers do I have to choose from for this outcome? 10, and for the letter? They're all going to be 10, 26, 25, and 24. It's just that the number's in a different place each time. So I'm just going to go ahead and fill in all these blanks now. You guys should be filling these in with me now. Now guys, these are all the same numbers being multiplied, and multiplication is commutative, so they're all going to have the same outcome. For this one we have 1, 5, 6, 0, 0, 0 outcomes for that one. And therefore so does this one. And therefore so does this one. And so does this one. Okay? So, altogether we need to multiply 1, 5, 6, 0, 0 by what? Because there's 4 of them. Or you could just add 1, 5, 6, 0, 0 4 times. I'm not going to do that. I'm going to multiply it by 4. It's the same thing. So we have 6, 2, 4, 0, 0, 0. Here is the answer.
Wait, how did you get 1, 5, 6, 0? 2, 1.
So here's 2 problems for you.